Hey guys, it's Lexi, and in this video on the basics, we're going to be talking about a super easy way to find hybridization. Okay, so in order to understand hybridization, I want you guys to remember that there are 4 different electron groups. It can either be a lone pair, a single bond, a double bond, or a triple bond. So if you have 1 electron group, that is going to be S for hybridization. 2 electron groups is SP. 3 electron groups is SPP, which corresponds with SP2. And then finally 4 electron groups is going to be SPP and P, which is going to correspond with SP3. Alright, let's look at a couple examples. If we wanted to find out the hybridization of this oxygen atom, for example, we're going to ask ourselves how many electron groups are around the oxygen. And if we count them, we've got a lone pair, and a double bond. So this oxygen has 3 electron groups. So the hybridization is going to be SPP, which corresponds with SP2. Let's look at another atom. What if we look at this nitrogen atom? This nitrogen atom has a single bond, and lone pair around it. So this nitrogen looks like it is SPPP, which corresponds with SP3, since it has 4 groups around it. Let's look at another example. What about this carbon atom right here? This carbon atom has a triple bond and a single bond attached to it. So it has 2 groups. So its hybridization would be SP. Here's another example. We've got this carbon. This carbon has a double bond, it's got a single bond, and then don't forget that it's also got a hydrogen right here. Remember, we don't show hydrogens that are attached to carbons, but they're still there. So if we include that single bond here, we know that this carbon is going to be SPP, which corresponds with SP2. Let's try one more example. Look at this oxygen. The oxygen has a lone pair, a single bond, and another single bond. So it is going to be SPPP, which is going to correspond with SP3. So the hybridization would be SP3. Now let's look at the one exception. If you have an atom that appears to be SP3 hybridized, but it has a lone pair, you need to stop and check to see if that lone pair can participate in resonance. So let's look at an example. If the lone pair on this nitrogen can participate in resonance, even though the nitrogen appears to be sp3 hybridized, we will not count that lone pair when we're doing the hybridization. So let's take a look. The nitrogen has a single bond, a lone pair, a single bond, and another single bond. So this nitrogen appears to be SPPP, which would be SP3. However, because the lone pair can participate in resonance, meaning it is delocalized, we are not going to count that lone pair. So the true hybridization would only be counting the 3 single bonds. So the nitrogen instead is actually not sp3 hybridized. It is actually going to be SPP or sp2 hybridized. Let's look at another example. Here we have the oxygen atom. This oxygen is attached to a single bond, a lone pair, and a single bond. So it appears to be SPPP or sp3 hybridized. However, because it appears to be sp3 and has a lone pair, we have to check, can either of those lone pairs participate in resonance? And the answer is yes. One of the lone pairs can participate in resonance with this ring. And because one of the lone pairs is delocalized, we are not going to count it when we're doing hybridization. We are still going to count the localized lone pair. However, we will not count the delocalized lone pair. So when we're doing the hybridization for this oxygen atom, it is not going to be sp3, but rather it is going to be SPP or sp2, since it has 1 lone pair that is localized and 1 that is delocalized. We will only count 1 of the lone pairs and then the 2 single bonds to determine the hybridization. Here we have a practice problem for hybridization, where you can try to determine the hybridization of the highlighted atoms. Go ahead and pause the video and then you can check your work. Okay, so let's start over on the left. We'll start with this carbon atom right here. Remember, this carbon is also attached to a hydrogen, so we have to consider that bond as well. When we look at the carbon, it has a single bond, a double bond, and a single bond. So the hybridization is going to be sp2. Now let's look at this hydrogen atom down here. The hydrogen down there is attached only to a single bond, so the hybridization of that hydrogen is just going to be S. Now let's look at this oxygen atom. This oxygen is attached to a lone pair, and a double bond. So the hybridization is going to be sp2. Now let's look at this nitrogen atom. This nitrogen atom is attached to a single bond, a lone pair, a single bond, and another single bond. So it appears to be sp3. However, remember that when an atom appears to be sp3, but it has a lone pair, you have to stop and double check to see if that lone pair can participate in resonance. In this case, the lone pair can participate in resonance, where we can move the lone pair to form a double bond and then move this double bond onto the oxygen to form a lone pair. That means we will not count this lone pair when we are doing hybridization. We are only going to consider the 3 single bonds, and the hybridization will be sp2. Let's go ahead and look at this sulfur atom. This sulfur atom has a single bond, a lone pair, and a lone pair. So it appears to be sp3. But remember, when an atom appears to be sp3 hybridized but has a lone pair, you have to check if the lone pair can participate in resonance. In this case, neither of these lone pairs can participate in resonance, meaning both of them are localized. So we are going to count both of the lone pairs when we are doing hybridization. And this sulfur atom is truly sp3 hybridized. Now let's look at this carbon. Remember, this carbon is actually attached to a hydrogen atom right here that we don't show, but it's still there. So when we're looking at this carbon atom, we see that it has a single bond and a triple bond. So the hybridization is going to be sp. Now let's look at this oxygen atom. This oxygen atom has a single bond, a lone pair, and a single bond. So it appears to be sp3 hybridized. However, because it looks like it's sp3 but it has a lone pair, we have to check if the lone pair can participate in resonance. In this case, one of the lone pairs can participate in resonance. We can move the lone pair to form a double bond, and then this double bond would form a lone pair on top of the oxygen. And so we're not going to include this lone pair when we're doing hybridization because it's delocalized. We are still going to count the localized lone pair. So this oxygen is not going to be sp3 hybridized, but rather it is going to be sp2 hybridized. Let's try the last example. Here we have the last oxygen. The oxygen is attached to a lone pair, and a double bond. So this oxygen is going to be sp2 hybridized. Thanks for watching. If you have any questions, feel free to leave them in the comments below. If you enjoyed the video, make sure to give it a thumbs up, subscribe, and also hit the notification bell so that you can stay up to date when I upload new videos.